All right, well, let's go ahead and kick things off then today. Welcome to this community conversation hosted by the Autodesk Community. My name is Chris, and I'm going to be your community host today. It's my pleasure to welcome Richard, and we're hoping Jorge will join us as well later. But for right now, we have Richard, who is going to be talking all about Fusion 360 electronics. So just a bit about our series here for those joining for the first time. Community Conversations are virtual meetups featuring expert speakers from across the Autodesk community. Sessions range from deep dives, tips and tricks, live demonstrations on products, to roundtables on industry insights or emerging trends, career stories, and so much more. And very quickly, we always throw up our safe harbor statement slide just to let you know that if there are any statements made in today's session that appear to be forward-leaning, do not make any purchasing decisions based on anything you may hear in this session today. Always look at the state the product is in right now before you make any purchasing decisions. So that's enough from me. You can see my name is Chris. I'm the Autodesk Community Manager for Product Design and Manufacturing. And I'm going to stop talking for now and let Richard and Jorge, who just joined the session. Hi, Jorge. We're going to let them introduce themselves and take it from here. So, Richard, let's start with you.
Okay, thank you, Chris. Hi, Jorge. Nice to meet you.
Hi, Richard.
Yeah, it's great that you made it. So, yeah, just let me introduce myself. Yeah, I'm Richard. So I'm working here at Autodesk since when? 2016, I guess. Yes, at the same time as Jorge joined. So yeah, it's a long time. So both of us became with the Eagle acquisition, and now my job is, yeah, my title is a community specialist for Fusion 360 electronics. But yeah, that's just the title. I'm doing all around electronics here. I'm based in Europe, being in the south of Germany. So I'm one of the guys who wants to tell people and show them what electronics is about, what we can do with it. And of course, as you know, Autodesk is very strong in all the mechanics parts. And now we have electronics since already also a long time, but that's pretty new. So electronics and mechanics, that's a different topic. So we really have to bring this together. We do this in Fusion. So we brought this into one platform, but the thinking of the mechanics guys and the thinking of electronics guys is different. So that's something I also want to show people and make them understand. And on the other hand, I do a lot of things with customers, with our partners, channel partners, and so on. And yeah, today we are here to talk about Fusion electronics and see what's new, what can we present, and what might be interesting for you. And with this, I hand over to Jorge.
Hello, everyone. My name is Jorge Garcia. Like Richard, came in the 2016 acquisition. And basically, if there's anything related to electronics, usually we're the people to talk to within Fusion 360. And it's incredible. We've been here already almost 7 years. It's gone by pretty fast. So we're here to share any questions, anything that you guys want to ask. We're more than happy to help. There's plenty to show. So if you guys want to see something specific, we're more than happy to show it as well. So thanks a lot, Chris, for having us on the community conversations today.
Yeah, thank you. So yeah,
these are always a lot of fun.
Yeah, they are. So let's take it easy. So okay, while there's no question at the moment, my question is when did we our last community conversations? I think it was in November.
It was November, yes.
It was November. So
yeah,
long time ago, and I guess we had some new releases in the meantime. And the last recent one was end of January, so not too far away from today. And yeah, what's the new things? So what can we point out? What did the electronics team concentrate on for this release?
Yeah, the biggest thing was just, this is the customer delight release, and the electronics team is very invested in doing this. It's a Fusion 360 initiative. Most of the teams are trying to do it, but we've really kind of doubled down on it. So January was a customer delight release. So the focus isn't so much on new features, or rather quality of life issues, maybe some defects that have popped up and were nagging our users. So for this release, it was all about fixing things and making life better, not so much about adding new features. So that's what we did. There's like a massive list on the forums that we posted with like 100+ things that were addressed and improved. And the general feedback has been that customers are happy with this release. Performance has improved. We still want to get it better. We still want to get it to be more performant than it is currently, but it's moving in the right direction. And in general, customer sentiment has been positive. So we've been pretty happy with this release. And I always look forward to these. These for me are actually my favorite releases, not so much the new features. The new features call a lot of attention, but the customer delight make life better in general. So
yeah, I see the same. So because I think, yeah, as you said, there are a lot of small things that might be annoying. We say, hey, okay, why doesn't this work this way? Or there's missing a little bit. So, for example, I guess there are some improvements in the library editor. We have seen a little bit improvement of performance in for example, importing libraries, as far as I remember. And we had some improvements in the content manager. And I think what's also new, what's coming to my mind now, is you can do library descriptions. That's something you could do it. I guess you had to type into the command line, but now we have an icon in the info icon, I guess, in the content manager, and there you see the list of information there. And if you click the description, then you can really edit it and write what's in the library, so you can describe it more or less, and you even can search for it. So if you look for something, for example, in the library manager, then you can also look for description or for keywords there. I think it's a really nice improvement. So that's something it really was missing. So you could do, but it wasn't obvious how to do it. That's something that's much better. So we have all these small improvements. One thing that comes into my mind is, I think it's that's not new, but you know the e-cooling stuff. So we can do a thermal simulation on the board, on the PCB, and even if it's an enclosure around, then you can of course also do the simulation in the product. Let's say, take it this way. Now it has been a long time already there. But now it's graduated from the testing phase now and went into the simulation extension. So that's something, if you have simulation extension, maybe you're working for mechanics, with mechanics, then of course you have also this now in the extension. But as far as I know, you can also do it without the extension, but then you have to, you have, I think one simulation is about 6 tokens or something you have to pay for. So it's still available, but it's really, it's pretty well. So recently we saw improvements in the simulator, and there's one new option. You can have, what is it?
In the e-cooling, you mean?
Huh? I'm missing the English word. So it's, if you want to check for temperature, so there's a pin. Now, what's this, a point? What's the name of it?
A probe. It's a probe.
Yeah, a point probe. Thank you. Yeah, that's the point probe. It was possible to place it on a surface, for example, but now you can even place it anywhere, even anywhere in the air, to say, okay, what's the situation, for example, in this area of my enclosure, even if you don't have a component or anything, so you can move it around and check for temperature, for example, or for air velocity. That's also something you can do.
Okay.
Yeah, that's pretty also new. So that's a bit of a change. Actually, not too many changes in the simulation tool itself. We have the probes, of course, but I think that's also a nice thing, and I like it. So that's something.
We take it for granted, but remember that when we did the community conversations in November, the SI extension had not come out yet.
Yeah,
So that's
that's true. SI extension.
yeah.
That's
So that's our biggie. That's our biggie in the time we haven't been able to do community conversation. It's the
yeah, that's
signal
true. So
integrity.
yeah, it came out just after the community conversation. So that's something maybe I'm just thinking of if we could show a little bit of it.
I have it. I have it ready.
Do you have it running? So do you have it? Do you have the board loaded, for example?
Yeah, give me a second. I'll pull it up so we can show a little bit of it.
So actually, you did a SI extension webinar in December, back in December in English language, and I did one just today, 2 hours before we started this one, German language. It was really great. So we showed people how it worked. We had a lot of attendees. This was very interesting, and I think that's really something that helps you and really pushes you forward in the design and increase the possibility that the board works at the first time and you don't have to do a reiteration. So that's really nice. And we had quite a lot of registrants, and I think we had nearly 40% or even more that really showed up there. So that's really good. Okay, but if you can show something, that's nice.
Yeah, I was looking now in my Fusion, and I requested it because now since it's out in the wild, you have to ask for it through easier. But
okay. So
but
let me. I could also let me share my screen. Then I can also show you a little bit. So I hope.
Okay, go for it. If you have it, then go for it, because they still
Yeah.
haven't given me access to the commercial one.
Yeah, no worries. I think
it'll be great to get some of this into the recording for people that watch this after the session.
Yeah, sure. Yeah, just we need a little bit more of visible goodies here. So that's Fusion. Let me just clean up because I want to move this away so that we see a little bit more here. So actually, that's the board we see. And I want to check something there. It's not really prepared, but I think it serves as a good example. Let me move a little bit things around. Okay, PCB. Imagine you're working on the PCB and you have something. You have some signals you want to check for impedance. So they typically have higher frequency. It could be a differential pair or something like this. And now that's easy to check. I think the usual way would be, to have the PCB done. You have it produced, populate the components, get it back, and then you do some testing. And it's not so unlikely that it doesn't work in the very beginning. So if you have no idea of signal integrity, and if you're not the best in mathematics, then it's really might happen that it does not work. And so here we can help you, and we have an extension. So if you look into your extensions manager, here you see it. I click here on this icon, then you see an overview what extensions are available for Fusion. And if you scroll down, we have the signal integrity. You see that's active for me. And even if you don't have it, you can use it, I think, for free. You can test it for 14 days, I guess.
Yep, you got it.
So just, select it, and it's available immediately. And if you do so, then you will see in the simulation menu, you will see an Analyze Signals icon, which finally brings up a panel here, which is the simulation Analyze Signals panel. Here it is. And now let's look into the board. If I go here into this one, and of course I pick out two signals I would like to analyze. Let me just switch off maybe the grid so it's a little bit better viewable. So here it is. Now I have two signals here. That's the DP and the DN. That's what I want to simulate. And I go here. Okay, what is it about? I think you're more the expert here. So what is it? Is it a USB connector, or what is it here?
Yeah, it's a USB differential pair. So like you mentioned earlier.
Yeah, okay. So, and if you're experienced, you would see there are some flaws in the design, I'd say, because what I do not like is actually too many deviations here. That's something. There is a via very close to the signals here. You see the polygon here, for example. but it doesn't flow and doesn't follow the signal path here. So we have some,
Yeah, and you'll see it. You'll see it
problems,
once you
might
run
have
it.
some problems here. So as an experienced user, you might say, okay, we have to adjust something. But if you're not sure, and if you would like to see really where is the problem, so where are the problems, then you could do the following. You just select the signal as I did here. I have D underline P selected. Frequency, leave it as it is at the moment. And I guess USB has an target impedance of 45 ohms or something like
45.
this. 45, and the tolerance about 15%. Let's
got
be
it.
generous and say 15%, that's okay. And now I just click here and say analyze signal. What's going on now? I see an overlay. You see the white trace is simulated at the moment, and you see it's very quick. It takes a few seconds. It's done. And now I have an overlay of the colors here. And if you look into the legend here, I see the target impedance would be green. So if this would be green, then we would be in the range which is allowed here. But you see, no, everything is yellow or orange or red. The more red, yeah, the higher the impedance here. So the more problems we'll see. And if you zoom in, then you can see, okay, in the very beginning we have problems, but it's in general, it's too high. So what should we do? See here, I have, of course, all information of all the segments here. I go here, I see even what's the impedance in this area, 74 ohms. We want to have 45, so that's much far too high. And if I go here and move this, you see all information about time, the resistance, what's the capacitance, what's the inductance. So I see all the information here. I could even export it into a spreadsheet if I want to, whatever you would like to with it, calculation, whatever. So yeah, what happened here? I used an ANSYS solver to have this analyzed, and now you can really begin in the design phase while you're designing your board and move things around and try to find a better solution. So what I would do, I'm not an expert, I have no idea, but I see, okay, I don't like this one here, for example. So what I could do is maybe we should move the via a little bit, push it away, for example. That's just an idea. So I'm here really doing it. So try and error. Or you're the expert, you would say, okay, start here and do this and that. So
So
Johnny's guru here.
So we can talk about it. Couple of things to note. Obviously, like Richard mentioned, the impedance is all off, so it's all wrong. It's not anywhere near our 45 target. But the other thing that's a problem is the fact that we have a wide range of colors. It's not a consistent impedance profile. So we have two issues. Number one, it's very inconsistent. And number two, it's wrong. So the first problem to solve is consistency, getting it a more consistent impedance profile. And then after that, then we try to, get it to match. And the reason it's inconsistent is what Richard kind of detected was that the polygon wasn't able to enclose all the way around the two traces. So any changes in the geometry in the cross section are going to change the impedance. And once he started making the changes, you see that immediately the analyzed signal panel notices that the signals have changed, and now the analysis is out of date. So there's a refresh button that he can use to clean it up.
Okay, so I just did a little bit moving around. So what I see here is the polygon flows better here along the lines. That's probably better. I have here a gap, but just let's do a reanalyze. So of course, Fusion detected, okay, there's a change in the layout design, and now just do a reanalyze, and let's see what's going on. So it's not properly routed, but you see here in this area, it's more the orange way here. So it's not as bad as was before. So I can really change this a little bit, and of course, I think the best way would be to do a reroute of the traces here and try to, if I look here, for example, try to bring the traces together earlier so that we have the correct distance. And of course, try maybe to increase the distance here, because also here the polygon is missing. Would be nice to have a little bit of copper around here. So the two capacitors here. Yeah.
So Richard,
Yeah.
if you can zoom in on this end, on the where it's orange, so down near the
Down.
beginning of the IC.
Oh, you're here.
Okay.
Yes. Yeah. Sure.
If you notice, there's a difference in impedance, and the reason is because the cross section near that trace has changed. The separation between DP and DN is different here,
Right,
than it is along the rest of the trace. That's what you notice, that when they get closer, it goes to yellow. So
right.
part of getting an impedance profile that's consistent is making sure that all these distances all along the length of the trace stay the same. And you know, if you have a long trace and you have a lot of routing, it's very easy to lose track of that. But the SI extension makes it very clear.
What if you
So
would do something like this? Do you think that would be better then? I know that's really a partial.
yeah,
work.
you're
I
gonna
think
have
it's
to
a better
reroute it.
idea.
You're
Huh?
gonna have to you're gonna have to reroute it. But you'll
Yeah,
notice that it's a little bit better now. If you go
yeah,
ahead and actually run it, it's slightly better.
yeah. So let's do the following. I will just hide the polygon pores, so I see a little bit more here, and then I would do a rip up or unroute of the signal. I guess I think that's the best way to do it. So let's see here. What should I do here? No, come on, move it on. Yeah, here we are.
There you go.
So I would unroute the connection, I guess.
Connection. Select connection, and then you click on DP and then DN.
DP, yes, no, here
Yep.
it is, and
There you
DP,
go.
DN. So it's undone now. And now I could start routing again. I used the, that's a differential pair, right? Or isn't it?
Yeah, it's differential pair.
Sure. Yeah. Cool. It's the differential pairs are defined by the underline P and underline N of the signal name, right?
Yeah.
So I have to go here and do a differential pair routing and click here onto this one.
Yep.
This one, for example. Here we are. Now, yes, now I could do something like this. So go out of the SMD pads and then go closer together and I have my
yeah. Try to stay away from everything else, so that way the polygon can show
try
better.
to stay away from everything else. That's easy said, but not
easy. Yeah, easy to say, hard to do.
Right. So let's try it this way. I'm not sure, but go here. Where do I have to go to? I move this away and go. Okay. Let's do a little bit of an. Okay. You see, I'm not. Oh yes, there's a via. That's something we should avoid as well. Maybe I don't need it. Okay, but yeah, okay. So this way and go down. Here we are, and then we approach these two guys here, and then I do an enter to complete. And if it's done, okay, that's not nicely done, but let's ignore this one right here. Okay, then I could show you the polygon force again if we want to. Let's show all the polygon force. Here we are, but it looks nicer as before, so it's really better, I guess. I'm not sure about the line width. I didn't pay attention on this, but let's just check it and let's see what's going on. Again, now I do a reanalyze of it. Takes again some seconds. That's really quick. I really like it. So that's something. Okay, 90%.
And even if it wasn't very quick, it's still very good.
Yeah, it's still very good. Now we have more colors, but we have an area where we have 50. We have the correct range. Where is this? Where do we have a green field?
Probably over
here. That's interesting. Exactly here.
Yes. So again, on that end, it changes a lot because we changed the separation very drastically.
Yeah, and what I also did not paid attention is about, I think the width of the traces is different as it was before, if I'm not sure.
I think it's the same width as before, but that width wasn't going to work anyway. It's still not.
Yeah. So, but what we can show is, of course, yeah, you see changing the path, changing the situation with the polygons, changing the close environment immediately affects on impedance. And one thing we could do is, of course, maybe that helps a lot is to think about the layer stack up. That's also something, of course, we take into consideration here. And just let me go into this one. I really I didn't prepare it. It's just an idea, and maybe
So I do have it back now, Richard. So I could
you have it
show.
back? Okay.
I have it back. I could show the final result after all the changes.
Let me try my result, and then you can try
Go
yours.
for it. Go for it.
So of course the distance between the copper trace and the copper plane in the inner layers matters, and that's something we can change. Of course, in the layer stack manager, you can decide about materials. FR4 is something, well, yeah, that's, there are other materials that could be used for high impedance stuff or for high frequency design. But just what I would like to try is, because if I have a smaller distance between top and route 2, I will just do a right click and I just do a delete. That's something you shouldn't do easily, because please, if you consider to change the layer stack up, talk to a board manufacturer, because he decides if this is doable. So I'm not sure if everybody would be able to manufacture this, but now I changed it as I apply. So it's applied to the board. We will see here the analysis out of date, and then we do it again. Let's see how it works. And if it does not work, then I hand over to Jorge, because he's the expert, as I said. Okay, it didn't, yeah, it helped a bit, I guess, because the values here are lower again. Oh, this one is too low. Okay. So yeah, you see, there are changes, but we have to play around a bit. So now I need a little bit of an expert who really has the knowledge what to do. But for me, it's playing around, and I think it's, yeah, we have done this for 5 minutes now, and I have a better result as it was before. It's really nice to see. And if you would like to share your design, Jorge, then let's do it.
Okay, go ahead and
Okay.
stop sharing yours, because it doesn't let
Yeah,
me share
I
what
will.
you're sharing.
Here it is. Okay.
Here we go. By the way, if anybody wants to comment anything or has any question, feel free to just interrupt us.
Sure. Yeah.
We have no problems with that. We know that maybe some of this electronic stuff is maybe out of the comfort zone of some that are present. So feel free to ask any question. There's no bad question. So here we have the analyzed signal, as we were talking about before. And this one already has the corrected routing. So first thing I'm going to do is highlight a couple of things. Number one, notice that these are thicker.
Right.
So the thickness of the trace has an effect on its impedance.
Sure.
The thicker the trace, the lower the impedance. As you saw in the example, in the original example that Richard was showing, it was always high. It was always out of range high. So by making these thicker, we now bring them down into the correct range. The other thing you're going to notice is that the separation between the two traces and the nearby geometry stays the same. So we have a consistent geometry. The polygon can fill all the way around. There's a little bit of a break here, but it doesn't create a problem. Again, you see all the way around on both sides. They're fully enclosed, and they stay together as long as possible. They literally only break away right here at the end. So that's
even as a non-expert, I see the difference.
yeah.
Yeah.
So that's a big part of getting consistent impedance. You want all the nearby geometry. If you were to cut the board down the middle, you want that to stay the same. Anytime that changes, you're going to have changes in impedance. So that's why you see it's very consistent all the way through. It has the polygon underneath, the yellow is all available underneath. So that all stays the same. And besides the thickness change and the rerouting, we have in the layer stack, the change, we eliminated one of the dielectrics. That way they would get closer together to the next layer underneath. So if you saw in Richards, there was like a division here. There was 2 dielectrics. I removed one of those and just left one. So now the 2 layers are closer together. And that also affects the impedance. So what we're going to do is we're going to go ahead and run the analysis. So go back to simulation, analyze signal.
By the way, of course, I can select one of the signals.
You can
And
also type them in.
yeah, and I could also, of course, you do the analysis for the underline, whatever it is, P now, okay?
Yep.
And
45 plus minus 15.
yeah, okay.
We analyze just like Richard had.
You guys may have answered this already, but is this being done, this analysis, is this local or is this cloud?
No, cloud. This is a cloud analysis because it
Okay.
interfaces with ANSYS servers.
Okay, gotcha.
Okay.
Actually, that looks good. But what I wanted to say, could you also check the other one? The
Yep.
D underline N, of course.
Let's do it. Now, one thing that's good about this is it preserves whatever analysis you do. So I'm going to do the D underscore N now, but the D underscore P does not go away.
Mm.
So
Right.
you can look at them side by side then.
Yep. You can jump between them. Okay, perfect. So you can
Looks
see now you
perfect.
can just jump between them. They're both in spec, and I just jump between them.
And if you do a change, then of course both of them will be reanalyzed, so to say, right?
Correct.
Okay. Okay. Or more
Yeah,
of them. So if you more of this differential pairs, then can this be done in one stroke, and all of the
correct.
signals are updated. That's really
Correct.
cool. So I really like it, and I like your results. So I see you're the expert. I'm the guy who just pokes around and tries and but of course you learn a lot if you just playing around is really interesting.
Yeah.
So in the webinar today we had I had an expert. He was a real professor. We did all the theory and all the stuff, calculate the maths and so on. That's nothing for me. So I'm more the guy who plays around. And but of course, if you have a little bit of knowledge of the basics, then it's really easy to achieve a good result. And I'm sure if you bring this, make this board and have it manufactured and produced and populated, I guess it will work from the beginning. At
Yeah,
least I hope.
at least I can guarantee the USB part. The rest of
Yeah,
it we
sure.
don't know.
Yeah,
But
sure. Yeah, but that's one thing you don't have to care anymore. So that works, and that's the nice thing here.
yeah, and really this is about empowering the PCB designer. This does not replace the ANSYS simulation analyst expert.
No.
This simulation is by comparison to what full ANSYS tools can do is very simple, but it gives you a lot of insight. So it's kind of like the 80-20 rule. You know, it's going to save a lot of money because it gives insight into key problems right during the design phase so they can be addressed, which will lower the possibility that the board won't work and then they'll have to redesign it.
Yeah.
In commercial situations, a board respin is very expensive,
Right.
costing thousands of dollars. So if you can minimize that cycle of respins, you're going to save money. Saving one respin is enough to justify the cost of the extension. So we feel that this is something that for most of our customers that are doing consumer products and dealing with USB, dealing with Wi-Fi, dealing with those types of interfaces, this is going to be helpful because it's going to be able to help them sort most of the big problems up front. And then, once they go to that first prototype, they're going to have a good sense of that there's a high probability that most of the issues are going to be worked out. That'll minimize respins. If they do have simulation experts on staff, then the simulation expert's job becomes easier because he's not going to keep running into this big majority of issues. He's going to be, they're going to be nailing down the final, the final 20%. Those things that maybe.
Sorry to jump, but that comes to mind now. And you have the option to export the whole board into ANSYS file format in EDB. That's
Correct.
something that's really cool. So if you need more simulation, then you could just export it and use it with the ANSYS software. And that's
correct.
So that's the path at the moment we have. That's really cool.
Yeah, so in that scenario where there is a simulation expert on staff, once you've gone through this and everything looks good from the PCB designer's perspective, then you do the export to PCB data to ANSYS, give it to that simulation expert, and then they take it the rest of the way home. And again, it makes their lives easier because they're not going to run into a lot of these kind of simpler things that are sometimes missed, but can long-term create a lot of cost in the product development cycle. So that's why this is here. That's the idea behind the extension. It had a good reception at DesignCon. A lot of people really understood what our intention is with this.
Okay.
And I see it really being something that's going to be really useful for our customers.
But also, sorry,
Yeah.
jump in here again. What I also like is, okay, here's all green, but it's so obvious if something does not really work. So if you see the red spots or red gaps or whatever it is, you see it. So it's always there. So you can't miss it. And what I heard from experts, sometimes they of course look into the design, and it can happen that you just don't look at this point where you should look to, and so the color display is really good. That's something that's obvious. And this, look here, there everything's red. You have to do something.
Yeah.
Yeah,
and
nice, really nice improvement for Fusion. I really that helps a lot, I guess.
it is. And the other thing is, there's nothing within the industry at this price range that gives us insight. That's the other thing.
Right.
Because as you saw, my input and the input that Richard and I have to provide is very simple. What's the signal, what frequency of interest, target impedance, and whatever tolerance is.
Yeah.
So with very little input, you get useful feedback.
And that's easy
what makes it valuable.
Yeah, that's easy to find this information, because usually you have a data sheet or something like this, and they say, okay, USB to whatever it is, 45 ohms, 15% tolerance. That's all you need. That's nothing you have to play around with. That's really easy to do. Yeah.
Correct. And it takes into account all of the layer stack managers. So the layer stack manager is set up that it can take into account material properties, and in other tools, the user would have to specify all of this. And what the permeativity of the materials is, like you see the DK, the DF, conductivity, relative permittivity. We already ship with most of the information for the most common materials. So from the user perspective, the accuracy of this simulation is actually very high. On top of that, it's powered by ANSYS, which is first in class in that industry. Their credit is good, as the saying goes. So, customers can feel at ease using it. And again, it's a really it's a new thing in the market. At this price point, nothing exists, because going full-blown ANSYS is a couple of orders magnitude more than the SI extension. So
that's true. But it's also, it's the first step with SI extension. I guess we will see improvements or additional functionality. So I know there are discussions about this, and there's something going on to improve or give you more options as well there, more insight. Yeah, that's very cool. Yeah.
Yep, we're trying to increase the value. This was the first pass. So as time goes on, this will include more functionality and more types of analyses.
Okay, cool. Yeah, thank you for showing it. So now you really see it. It was very nice. Yeah. Okay.
So hopefully we can get a lot of people to watch the recording of this and see your demonstration, and you'll get more feedback, more comments, positive comments.
Yeah, and this demo set basically has a video series on the Fusion 360 YouTube channel that goes through what we just did in full detail. So it goes from the initial board that Richard has, which has all the problems, and then the different stages of refinement until you get to this one. And then there's another video for how to extract even more information from the extension. So even though the extension is very easy to use, it actually gives a lot of insight, and a lot of other further processing can be done with the data that it provides.
Right. Cool. Very nice. Okay, but that's something. Yeah, we released this. Yeah, in November. True. Yeah, it was short after our last community conversation, and yeah, I guess this year we will see lot of improvement for Fusion again. So
Yep.
what I have in mind, next
We could-
release is planned to be end
March.
of March, right? I think March 30 or something like this.
Yeah.
So yeah, I'm really curious what they're really.
Yeah, we can talk a little bit again, since we had the safe harbor statement. We can talk about some of the stuff we want to do.
Yeah, true. That's true.
You know,
Yes, okay.
we want to improve some design rules. We want to make design rules a little bit more powerful, a little bit easier to use. Some bill of materials information, functionality we want to kind of implement as well.
Right.
Improvement in the differential pair routing with the meanders is another thing on the plate for this year.
Right.
So there's a lot of work. There is a lot of work and some other things, but those are the ones that kind of stick out to me in my mind.
What I would like to see, and I think you just mentioned it, I think that's very important, and I don't know how it will look like, but bill of materials, that's a topic that's really something we should work on. So
it is.
of course you can export data, that's not the problem, but yeah, I need more information. I
Right.
need better integration into Fusion. I need yeah, better handling of all the data, and that's
Correct.
something.
Distributor information, being able to get real-time pricing information, stuff like that. I'm going to throw it out there, even though I know it's not going to happen, but I would love to see electronics in the Fusion API, the Python API.
Yeah, that would be nice,
I throw this out every chance I get, but I would love to see it. I know it's probably not a priority for this year, but it'd be really nice to have it, because then users develop, and you know, we coming from Eagle, where our customers made a lot of tools themselves using the UOP language and the scripting engine that Eagle provided. You know, the Fusion API is just so much richer that I know they would do a lot more with it. So, but
yeah, that's true. Yeah, that's also something that's really would be not just a nice to have, that's something
I think we would see
so many additional. That's true.
We would see the capabilities grow so much. You know?
True. Okay, let's wait for the next releases. Maybe we see it this year, next year, whenever it is. But I know that our dev team is aware of it. It's just in quotes a matter of time.
Yeah, I know. But I'm telling you, I'm gonna throw it out there every chance you get.
Yeah, you just got to watch it keep moving higher and higher and higher on the list, and eventually,
eventually it gets done. Once the priority,
just don't let them forget about it.
Yeah, true. Yeah, you have to poke them every time and say, "Hey, come on."
Yeah. And then they tell me, "We know, George. We know. I'm like, I know you know, but give it to me.
Get it done.
Okay,
So with the new releases coming out, it sounds like you guys will have plenty to demo on the next conversation.
Yeah. The net March will have some new functionality that we can show.
Yeah, sure.
That'll be great. Looking forward.
So I guess we have every time we have something, we can demo something. So there's always news, and there are also some topics maybe or areas in electronics we can show, but because nobody knows about. There are a lot of workflows and options that we can show. So think about combination of command lines or not combination, but combination of commands in the command line, assigning to a function key or to a key. And then what we also, I think a lot of people are not aware about the assembly variants we have, the variants in schematic, for example, or we could, there's something, the hierarchical schematic. So I know there, that's my opinion, not speaking for anybody else, but I imagine, or we need improvements in this area. But it's also good to have some module sheets, and you have some module instances in a hierarchical schematic. That's really nice to, if it's a little bit more complex, then it's much easier to read, because this module, this and that and that. And if I want to have the details, I look into this module instance onto the module sheets and see what's the schematic behind this. That's I've seen this not yeah, quite often in the customers they're using it.
Yeah, they are.
That's also a topic, but yeah, that's something we could also talk about.
It is, and that's also, I think, something that's slated to be improved as well.
Yeah,
Working with the modules and making it better.
true. Yeah,
That's an advanced topic in general, though. It's the idea of abstracting.
yeah,
Abstracting circuitry. So instead of looking at all these components and all the circuitry, treating it like a black box and then only worrying about the ins and the outs.
yeah,
So in really, really sophisticated products, it
yeah,
helps lower the mental load on the whoever's doing the systems integration, and it allows for a better division of labor, because then you can split up modules between engineers. You do the power supply, you do the CPU and its support circuitry, you do this, you do that, and then at the end they just put those modules together and interconnect them. So that's something that a higher end customer generally leverages, but we are seeing users using it. So anything we can do to make their lives easier, that's going to be kind of on the table for this year as well.
Yeah, true. Okay. Nice.
Any questions? Anything anybody would like to comment? Feel free. If there's anything we can do to make these better for you, if there's anything that would be more interesting, please feel free to let us know.
Yeah.
Don't forget the comments can also be added on the community conversations page for this session. Let's keep the conversation going after we're done today, or if you've watched the recording on YouTube, you can comment there as well, and come back to the community conversation page and start a conversation there.
Yeah.
Keep it going.
Yeah.
Sure. I don't know, Richard, if we want to give them back 10 minutes. We're basically pretty much there.
Yeah, that's a good idea. So yes.
All right. You want to stop sharing,
Sure.
Jorge, and
Yes.
I'll close the session out for you. All right, let me share my screen again. All right, well, I want to thank everybody that is either in attendance today or viewing the recording of this later. I want to thank Richard and Jorge for another phenomenal demonstration. I don't do electronics, but I learn something every time I watch you guys. It's just amazing. And in another 2 years, you'll have me doing PCBs. Who knows?
There we go.
Yeah, that's the goal here.
That's the goal. Yeah. All right, so if you're interested in becoming a community conversation speaker, we do have a proposal that you can fill out, a form that you can fill out to get your idea in front of us. Just scan the QR code or go to the link on this slide and let us know what kind of ideas you've got. And we hope as well to see you in the community in our various different programs and projects that we've got going on here. We've got community conversations, obviously. The group network, the industry communities that you can join and follow. We've got our discussion forums. We are on Twitter and Facebook and also on LinkedIn. And we have our 2 blogs, the Community Journal blog, which is a blog that is written by the community team with news and information for you. And we also have the Community Voices blog, which is a blog written by the community and for the community. We also have our new tips and tricks currently in the AutoCAD pilot, and we're going to be moving that around to various other areas in the future. So just come to the community page and check out all of these great resources that we've got out here for you, and become a part of the conversation. So once again, thank you, everyone. Thank you, Richard. Thank you, Jorge, and we'll see you all next time.
Bye, everyone.
Bye, everyone.
Bye. Thank you.